Then I moved to Delhi in 97 to build the first Institute of Genomics and Integrative Biology, realizing that the computational strength that India has and the large genetic diversity that we have, once the genome sequence is in the public domain, we should be able to integrate these two for function. And that brought me to build this institute, which looks at all sorts of large-scale genomic data, which I led for 10 years as a founder director. Then, of course, I started this open source drug discovery initiative. I was a member of Human Genome Organization from 1990. I was 7 years member of the Hugo Council. I felt that the genomic scientist has committed very largely for saying that the genome will help, data will help public with affordable healthcare. But as you know, the healthcare has become more expensive than ever before. The drug discovery has reached $1 billion plus $2 billion for a new chemical entity to come. Investment has gone up, but return of investment of new molecules is small. So this juncture, I came up with an idea in 2006-07 that how can we make drug discovery open and open source? If Linux can do open source, 95% of the computers, of the supercomputers in the world are operated through Linux. There's no reason at all why we cannot take the drug discovery out of the realm of pharma company. Because all the basic science, billions of dollars, National Institute of Health, billions of dollars all over the world people spend, but the last mile we leave it to pharma. And this is especially so when it comes to neglected disease. And the diseases like tuberculosis, Ebola, or malaria, and so and so. So the issue was, yes, genome is available, but we haven't understood the meaning of the genome sequence. It is a beautifully written Shakespearean sonnet, but we don't understand the language or the meaning of it. Can we then decipher human and do a complete computational model and build it of human? My answer was, it'll take 30 years of more data. But can we build for any disease organism which bothers us? And just to give you a feeling, 4,000 people die of tuberculosis annually. Sorry, per day. 4,000 people die tuberculosis per day. In India, 1,000 people die this evening. So therefore, it is far more than a confusion that gets created with 50 people dying in Ebola, 1,000 people dying in Ebola. However, the world has taken it granted because it's most of the poor people who gets affected. However, the multi-drug resistant tuberculosis has caused very serious problem across the world and nobody is safe. And we have seen this for SARS. It is true for all infectious diseases. So my idea was, can we start and build a platform through crowdsourcing and convert all information that is available in literature, all published documents, structured data, unstructured data, through a semantic web-based search engine and put it into such a way that we can have thousands of people can participate. You know, India's biggest strength, we have large number of students who are hungry and do not have adequate resources. They don't get the opportunity of such classes from so many experts of all of you with brilliant ideas, which I saw in the topics. So the idea is, can we use this also an educational platform while they do some meaningful research? So that's where the idea came, and fortunately, or I don't know, I was also asked by the Prime Minister to take charge as a Director General. So in the process, fund was easily available, but we didn't need too much of fund. But organization could come in very easily. And what we did, we built a platform called, so you can go to the site called www.osdd.net, osdd.net. We built a platform called SysBorg, System Biology, SysBorg of organism, SYS System Bio, SysBorg 2.0. where we could then crowdsource about 1,200 students across the country, and we made our portal smart cell phone compatible, and we had to read about 27,000 published scientific documents on tuberculosis. The existing annotation with genome sequence done at Pasteur Institute in 1990 and 2002 was about 52% of the genes were meaningfully identified. We finished this by 99.5% of annotation by crowdsourcing. And we had, from 1,200, we had shortlisted 800 students who could go through some tests, because you gave them 1 or 2 papers, see how accurate they are. We also gave micro attribution so that we can see who is scoring better, who is doing well. And then finally 400 people, 400 students, they are all bachelor students, master students, PhD students across the country, especially from colleges and universities which are less endowed, which has less opportunity. And in the process, we could convert about 300 man-years of work in a year's time, in 10 months' time. And, Bernard Monod, a very famous pharmaceutical chemist, was in Eli Lilly, chief boss. He wrote about it, and several people have written about it. And so therefore, this became the first evidence we call connect to decode. So we connected people to decode, C to D. And this connect to decode became the first crowdsource scientific annotation in a scale which was very large. In the process today, we have the largest collection of all the information. And now based on this, we built a computational model of all the organisms, as if we are trying to build like a 777 aircraft or 787 Dreamliner or 380, which are built in computer. Whereas still 747 that we fly, they were all prototypes, started from Wright brothers to now. Unfortunately, drug pharmaceutical industry, I hope there is nobody from the drug pharma here, has remained in Wright brothers era. They would try and fail. No wonder, with so many brilliant minds of United States, all over the world, with so many intellectual property held by United States and the lawyers like Beth protecting them, in spite of a National Institute of Health effort, somewhere something is wrong that our discovery cost goes up. And everybody has to pay far more. And I feel sorry, especially for people of the United States, because you pay so much more for the discovery that you did. So my idea was, can I create an open source pharma initiative? I don't want to do cancer because I'm sure I don't want to be shot dead. I just want to stay on tuberculosis, Ebola, the people, which are malaria, but we decided tuberculosis. Because I can tell you the problem is big. I don't know, some of you may not be scientists. So it has 4,000 genes compared to 20-odd thousand genes in human. But it is a combinatorial. So you can see the number of interactions in human is trillions, whereas here 4,000 leads to, you can see 4,008 numbers here. We realized that the actual bacteria uses 890 genes out of 4,000 to do all the metabolism and grow. It does 1,152 reactions and uses 961 chemical metabolites. So we built all this in computer. Based on building in this computer and simulating them, we could actually identify new drug targets, new drug leads. And so therefore, the first time through crowdsourcing, we have actually built. Now, what did we do? Who gets the credit out of it? First, out of those 800, 120 who did very well were brought to Delhi to have a jamboree with many brilliant scientists from across the world joined them. And a philanthropist gave a laptop to all of them. So 120 laptops were distributed. Students were great excited. They did not expect anything. They wanted to contribute. Only thing we did, on the back of the laptop, we put a sticker saying OSDD. Very big sticker, all over the back. When the students went back to these colleges and institutes, everybody said, wow, you have a laptop. So I had 50 more students for each student started joining in. So we created a crowd of 8,000 students today across the world, including from Germany to Africa, from 130 countries are on the portal. But any given time, about 20% are active. Majority of the crowdsource data collection is over. So we are now building models and moving into chemistry and looking into drug discovery. That also we are doing through crowdsourcing. So we are doing crowdsourcing of 400 students who are doing modeling of small molecules to the targets. And this we taught them. None of them knew how to do chemoinformatics. So we used professor of Indian University, professors from Berkeley, and the students sitting here through our coordinator and our students actually teaching them. You will be surprised that today it's evening early, but professors of Indiana or Berkeley were not willing to come up so early. Beth is very in the jet lag, so she doesn't mind. So they will be, when they were speaking, it was dinner time or late dinner, 9 o'clock, 10 o'clock. But I have seen the girls and the boys waiting for that teaching course. Today I have the world's largest, we have the largest manpower trained in chemoinformatics. Now what did the students get? Do they get money? You'll be surprised. Since we put this micro attribution, we could see anybody contributing 1% of the contribution of the paper, we make them author of the paper. So I have a co-authored paper with 49 co-author drawn from 29 institutes, of which 20 of them I have never seen them. They have come on Skype, they have contributed through online, they didn't have any money to travel all the way to Delhi and go back, and so therefore we organized another meeting when the paper was accepted to meet all of them so that we get a chance to meet each other. So this is first time a college student in a remote place of India becomes an author which is published in international journal. The second benefit they get, their contribution is all marked. Everybody knows who has annotated what. Even Stanford University and Broad Institute has used 70% of those annotation for their work, and they have acknowledged those names in their database. Now these students then get opportunity. Those who do best, we select them for PhD program, and they can get the chance to come and work in the laboratory in front of us. So, in India, we have these young students like hero worshipping. So I enjoy that, but I don't think it is a great idea. But they'd love to come and work with you, interact with you. So that's the attraction to bring out of hundreds, you bring some 10, 5. And many of them then get fellowships abroad because they could show their result that they have done, which is online, available, acknowledged. And today I know dozens of OSDD people, or I'll say hundreds of OSDD people are across United States, Germany, Europe. And any university I go, suddenly somebody will come and say, hello, I'm OSDD, I worked on such and such date. So that's a great pleasure. So I can say, here's a story where we have taken, I will say this way, Manhattan Project was the first, one of the large crowdsourced scientific projects, but it was closed door, led to Cold War. Then came Human Genome Project, but that was a project we made sure it is open source and shareable, because it doesn't become a part of the Cold War. But Human Genome Project was again a project of experts, not raw novice. India did not have any expertise when the Human Genome Project started, so we could not join. China joined with the fag end to with 1% contribution. But this is a project of the novice, which bring this novice into a crowdsource. So I call it the true citizen-student crowdsourcing event, where you make them, educate them, teach them, give them SOP, and then eventually it's an educational exercise, but outcome is a solid scientific outcome. So I thought I have explained the crowdsource part, and I'm sure, I think Beth is okay.
More than okay. Really, truly exciting and inspirational. Do you want us to, can we pepper you with some questions at this point?
Sure.
So I'm sure we have, people can, what we can do is send the questions in the chat, we can raise hands, we can dive in. I don't think unless it requires moderation, we won't impose any. But let me start just to ask you a little bit about the mechanics, coming back again to the audience of the 4,000, which then got winnowed to sort of 800. I want to go back to these numbers again. The 400 students, and of which the 120 got the laptop. So there was 800. I just want to come back again to first, just if you could, how was the initial cohort identified? Were they all people who volunteered? Were they selected? And then you gave them an exercise to annotate 1 or 2 articles to see how they did. How was that judged? Who did the judging? Just come back again a little bit to the mechanics of the crowd.
So I'll tell you how it was. 2 of my associates, young associates, and you want to understand, when you try a new idea, nobody older age believes you, who has experience. Do not think that it will work until others have done that enough. So they were very young. 2 of my young, one of my student and one of my young postdoc associates, Anshu Bhardwaj and Vinod Skaria. So they put it up an ad and giving a time that we are going to do some big jamboree online. Whoever students wants to join, please join. And this was put into Facebook, Twitter. It was just crowd. It was sent all over. And students started registering. And 1,200 is not a big number in India, okay? And when you count up crowd, and huge, so students came in. Then what we did, in the beginning, we gave them all one paper identified. So first we gave them an SOP to understand, and then we gave them, I think, 1 to 3 papers each. From this, we could shortlist 800, and this was evaluated by us, already annotated. Within 52%, you pick up and see whether they go back and annotate the correct, which is already the area we know very well. And from that, then you pick up 800, and then 800 started working, and the time frame was very important. And we started giving 3, 10, 4, started assigning. Then we formed groups. Each group formed subgroups. Originally, we had kept some mentors in the top and the young students, and the designation was known to us, known to each other. We just realized that 1 or 2 groups are doing very badly. It's not moving. Then we realized that the most of the ideas that students are proposing, the mentor is actually rejecting. And mentor is a PhD or somebody. So we decided, remove the title of everybody. Let nobody know who is PhD, who is non-PhD. And it turned out, they organized a hierarchy where the most performing person started instructing and correcting others. So we thought curation will be a big headache. It suddenly got solved. And now we discovered a second-year bachelor student is leading a team where a young faculty is actually involved and is a participant. But they don't know. I know from my administrative angle. So this was a great learning that you allow them and they will be able to make a difference. They form their own hierarchy. So therefore, shortlisting when final 120 depended on actual content of quality. Now, how did we get scoring? So we created, Indian students are very competitive. They like to beat their neighbor very much. So we said, if you do correct, you get point. If you find others' fault, then you get more point. And other loses point. So now everybody is competing to find fault of others. And you can see we put the Twitter and the Facebook for closed door. And they were tweeting, then saying yours is mistake. That person fights back. So there is an editor, one of my young colleagues was sitting there. Her job was to say, now enough fight. This is the final decision. We will read the paper and get back. So in the process, every gene annotation was actually checked by multiple people in order to see there's no error. And this is how we picked up the last 100-odd people. The laptop was not promised. Must remember, none of the students can afford laptop. They work from their college computer, somebody else's computer, and many of them worked with smartphone because we made the server smartphone compatible. So they go to the library, they do the reading, and then. Our biggest challenge was non-open source papers. How do we get papers which are published in Nature Science, and the students cannot access open source. So 3 students volunteered to email to all authors, thousands of authors, to collect about 40% of the 27,000 papers which was not available open source. Those papers were on the courtesy of the authors. All authors responded. That was fantastic. So we created a non-open source publications through the author, an open source directory in our portal, which all other students could see and make sure. So this was done by 3 students. Then the student themselves came up and created what I call a call center. So 3 students decided that they will attend anybody's call throughout the night on shift. Anybody has a doubt however they're getting stuck for because they don't understand what the protocol is, SOP is. And so it was a fantastic crowdsourcing. And I must tell you, I did very little other than the idea, other than motivating once in a while, getting on Skype and motivating. It needed physical presence. I think I might have gone and physically given about 12 to 14 places the lecture, but about 600 Skype calls in which I'll come for 5 minutes because I was very busy. I'll come and say, what is the purpose? You know, there's a great saying of Vivekananda, which says that if you leave and you leave for others, then you leave. But if you breathe and do not leave for others, then you don't leave. You are living dead. So that was the catch point. And I said, affordable healthcare is a right for all. And it has to be a balance between business and right for all. You cannot have business alone. And so therefore, and then the students came up and created a song. You can go to the site, OSDD, you will see it, there's a song, and the students created a song that we will make a difference of the life for people. So it became from a professional enterprise to an emotional enterprise. So nobody was looking at reward. Even today, nobody looks for reward. Everybody looks for to be a participant, takes a great pride to be a part of this crowdsource initiative. So I thought I'll explain to you how it was all developed.
If you open your chat window, you'll see that you have questions coming in. People may want to ask them, but there was a point of clarification from Kevin.
Sure. Sorry, just to clarify, what were you crowdsourcing? Were they annotating a literature review? Were they annotating each gene and what the research said that gene did?
That's each gene, each protein-protein interaction, each written function, their Go annotation, their interprotein interaction annotation, their biological function of 4,000 genes in published literature of about 27,000 published papers.
So just a massively long paper on what each gene did and how it interacted.
Each gene will have maybe 10, 12 pages of paper, length each paper, and 27,000 such paper had to be read physically. Everybody does annotation computationally by reading the text. But we found that there's a lot of error. When you annotate human genome, nobody has read all the papers of 20,000 genes of human to annotate. All I can tell you, 300 cancer genes will need 60,000 papers to be read. Nobody has done it. So whatever you get is largely computational annotation and then experimentally validated, limited. But to put them together as a system, you need to annotate all of them. So that was the job that we had for tuberculosis genome.
From Jason and Juan Camillo, you now have a couple of questions about what role government played and the funding model.
Okay,
you can see their questions, and if they want to amplify them, the concern seems to be that this cost a lot of money to run, and so I think that requires some clarification. And then after Matt has had his hand raised and been waiting.
Okay. When I told the proposal for this, I requested $120 million when I was not the Director General. Please remember, you ask for money to others, always larger. But when you become Director General and you have to delete that money, my biggest challenge was the day I released $120 million for myself, I may lose my job because all my colleagues will be who are younger directors. I have 40 directors to fund, so my pet project cannot go. So I only allocated only 10% of it, only $12 million.
So,
And $12 million over 5 years, we accomplished so much that this number I was not supposed to disclose publicly. You will get all literature, $38 million, $120 million. Any review on OSDD you read by Cell Press or Nature, wherever you will find the book called, there's a book by already, then their WHO report, you will get numbers of the order of 38 to 120 million, but they are all budgeted. Actual expenditure was very small because the project was managed by only 6 people to start with, and everything was crowdsourced. And computational resource was a national knowledge network, NKN, which is available to all institutions, all colleges through which we did. And we also use the National Supercomputer Facility, which sits on NKN, Garuda, and it was available free because in India, computation you don't pay. So it was eventually, as of today, I know another 2 million, another 3 million for clinical trial is being allocated for the new phase, a 3-drug combination therapy, which is partly contributed from TB Alliance as a joint venture. We now have DNDi, Drugs for Neglected Disease Initiative, MMB, and then DNDi, TB Alliance. Royal Society of Chemistry has given fellowship. Royal Society of Chemistry provided large amount of software and access to free. Also, the Cambridge University professors and several of them proprietary technology of fragment-based drug discovery. They provided Professor Tom Blundell, fellow of the Royal Society. From Berkeley, there are students contributed. All I can say that financially we had most of the money was paid initially by the government because I convinced the government, and then still $100 million is government has cleared, but it has not been released to take it further. But I don't think that much money is required anymore. It is because the discovered molecules will go into generic stage, and India makes generic drugs very fast, very cheap, and they know how to take it through. Clinical trial cost for each molecule, we realize if you have done smart job, is about $22 million. So we are going to finish the first trial within less than $5 million. So whether it will come through or right or wrong, we don't know, but that's the cost. So we were bringing down the scale of everything by a factor of 20 to 50 at a lower cost. And remember, the students' incentive was more is motivation rather than financial incentive. And we use all existing facilities nationally available across the country for chemical synthesis. So we have done recently a crowdsourcing chemical synthesis. We have about 100,000 students across India is doing chemistry lab, boring lab, what they're seniors to seniors. Everybody has done their life. They repeat those experiments, synthesizing this, synthesizing that. We said, why not we get crowdsource a set of molecules which becomes a library? So today we have a huge library, chemical library, synthesized by students as a part of their practical learning process in master's program. And this is coordinated by 100 teachers. So you can see, you are using the same resource, same chemicals, which should have gone into the waste in the sink, is now being used, same way biochemical assay, same way the existing facilities, sequencing facility, all sorts of things, existing hospitals where we are getting clinical sample, and including government hospital, which has agreed to do the clinical trial for 500 multi-drug resistant TB, the 3-drug combination, which has been just started, and all I can say, we have started the patient recruitment, for which $2 million is given by CSIR. However, Tata Trust has given a very interesting fellowship, which will might, again, to crowdsource housewives, the women who are at home, to give them a fellowship so that they can contribute as a crowdsource. So we have a 50 women fellowship from Tata Trust. We also have young, among the smart kids, gets a Tata Trust little fellowship, which will be maybe $200 a month, but that is good as a top up of whatever they are earning. So they feel good. So like that we have done, so this is how the model works.
Samir, this is Kareem Lakhani. Thank you so much for your presentation and your discussion. It's very inspiring. I wanted to ask you, just to, what you've done in many ways, as you know, people have said there's no way you can organize this type of an effort and get this kind of work done. I mean, I'm sure there were, even now, there's like a lot of skepticism about it. Could you sort of think about how we take the principles you have developed in the scientific domain and say, how do we take them to sort of the social innovation, social policy issues that many of the participants are dealing with? Yes. For example, Maha is trying to do something around, bottoms up, reconciliation of ethnic conflicts, right? Other people are trying to build systems on policy analytics. So how do we take your principles and go beyond science to the world of social policy?
Yeah, I must first congratulate Beth for providing me this type of projects. I'm amazed and actually impressed that how all of you have thought so innovatively. And I must tell that the Paris Assembly, we have seen so many types of innovation people have done. I have thought about it, and I can tell you, those who learn OSDD, they immediately look at an opportunity. And one of my younger associates has done a very brilliant things. In India, the government spends money, but the garbage doesn't get cleaned. So he has come up with a portal where you take a photograph of the cell phone and public, right, and upload it. And similarly, somebody has come up with an idea that some of the roads are not repaired, although government record, they're getting repaired. So in this process, one of the parliamentarian, he actually used, public has used photographs of potholes and kept uploading. And when this upload is taking place, public is actually contributing. And actually that whole area of the constitution of that parliamentarian, there is no pothole on the road. In the city of Bangalore, it is the same thing with the sweepers. They have been told there's a GPS location. You take a photograph before you have cleaned. You take a photograph after you have cleaned and upload it. Since the GPS location is fixed on the phone, the database actually maps and says this place is clean. Then any public citizen at the same location actually takes a photograph and shows. Then it will be, if it is not clean, then that person gets problem. So it's an amazing way public can keep a watch on a crowdsourcing of contractors' work for which government spends money but gets little. So like that I can go on telling you there are examples already happening, and I actually get amused that I think some of them, I don't think all of them, but I can tell you there are new ways. I saw even this Paris Assembly where health records, I can give an example. In India, we are very, very easily tell our disease to our friends, our relatives. Our all personal health record has no confidentiality. My family, my brothers, sisters, cousin, everybody knows my blood sugar has gone up. And so they don't give me the dessert. They pull the dessert out when I go to their house. Everybody knows everything in India. It is nothing to be ashamed of, nothing to be hidden. It's very different than your society. So therefore, can I crowdsource? India is a haven for medical record crowdsourcing. Nobody will come on your way to, So you can imagine what fantastic. I don't need legal lawyers. What I meant is simple. I tell you why. I'm sorry, Beth, if you may not like this statement. I tried with AstraZeneca, Pfizer to work on my discoveries on novel targets for tuberculosis. Every time a lawyer came in, the agreement fell off. We could never achieve it. Then I thought, what can I do when I don't have a lawyer on the way? And I can tell you, OSDD is the most brilliant thing where it doesn't mean you don't take an intellectual property. You can take an IP, but you donate it back into OSDD. And what you take from OSDD, if you value add, you're supposed to get it back. Through our SysBorg, which is maintained by Infosys, India is one of the largest IT company, The chairman was a friend, so I could tell him that do pro bono, and he did pro bono. He made a commercial. The server, I heard somewhere the scale-up has a problem. You won't believe. The president, we had a very popular president scientist, Sir Abdul Kalam, and he was very fond of OSDD. So everywhere he will go for a talk, he'll talk about OSDD. And the moment he talks OSDD, I get thousands of hits on the server, and the server collapses because server is sitting at CSIR. Then we realized it will not work, so we got to National Informatics. We got our server placed there so that it doesn't, and we told him that, sir, before you talk in a public place, in convocation address, mention OSDD, give us a warning. We will be careful with engineers to make sure our server doesn't crash. So, so there are people who took it up. And I'm sure Beth has seen that I have not talked about OSDD to you. It is Jaikumar Menon who made it so public. And I have talked so little, but Jaikumar Menon made it in the conference much more interesting and exciting and made everybody's interest. And I have so many mails now, I don't know how to handle. I am supposed to be off holiday from tomorrow. My wife is coming, and that's why this 1 week, but then I'm stuck with so many mails. So what I meant is, it is applicable to many. I have not deliberately looked at the diseases where pharma makes a lot of money because I'm afraid that I don't want to get into conflict. I am trying to tell pharma that here I am training thousands of people in drug discovery. Here I am building a model which will make the cost lower. Maybe your profit goes up, the shareholders benefit. So therefore, I'm your friend, I'm not your enemy. Open source is a new way of doing business. And it is completely applicable to social. Anything you can imagine, one can organize it. So I believe we need an international foundation now for open source. And I'm very keen to start this. Today only I was discussing with my colleague, Ganesh, maybe we need to have a small foundation created. Because now I'm not in office, but OSDD, I'm still the chief mentor, and OSDD, anybody can be a participant. You don't have to be an employee of CSIR. It is CSIR-led Team India initiative with global participation. So I continue to be, and all these younger people look at me to do. So I was thinking maybe we need some resources beyond government, because there's somebody has mentioned a resource. So rich lawyers can actually donate and pro bono time. Of course, they put pro bono time, spicy, but also rich get some money into a foundation which can be international and bring international people best mind. So my argument is, like Bernard Bono, like retired of people from AstraZeneca, best minds you can bring in, use young people to do the job, and then take it to as a generic, new discovery, make it a generic, take it to the pharma who are generic industries. And Israel's, I have talked to Teva, and of course India, Cipla, they're very excited. And they are the one who has made the affordable HIV drug. So it is the Lupin, Cipla of Indian generic companies, along with Teva of Israel, can make a difference.
Sorry, I just had a quick question that might be a little too nuts and bolts for this discussion. So if it is, feel free to let me know. We can take an answer offline or anything. Just wanted to first echo everyone's thanks for participating in our class this morning. And wanted to ask a little bit. So it sounds like from your contributors, you needed them to lay out a lot of very specific information. And I was wondering, kind of as they started their contributing, if you did anything in terms of laying out a format that you were requesting this information, all their contributions in, or if you kind of let them present the information without a format and then went through and kind of help them massage it into the right format.
Okay, it's a good point. In the beginning, we realized that we need multiple expertise. So I was responsible for computational modeling, all computational annotation data. Below me, I have one younger colleague who was looking at IT aspects, and one was looking at all the information that is coming in, the process of crowdsourcing.
It's 9 o'clock.
Then we had one more person who was looking at exclusively all biological research resource. Similarly, one was lastly looking at clinical trial project. So everybody then meets, the chemistry was looked after by somebody else. So we brought leaders of the national laboratories to help us in this. Then we got international leaders to come in and participate, because each of these leaders knew some of the English. So we had a core team, maybe about 10, 12 experts, including Tom Plannell from Cambridge. And then, but we had a policy. My job was to, every project before funding was to go through a policy group. And finally, after the policy group, I had a look overall, unless the project was $100,000 or more, or maybe more than that, $150,000 or more, I was not looking at myself. But the moment $150,000 or more we are spending on a project, which is a sub-project to do experiments based on computational work or to buy resources for computation, all this went through me personally. So therefore, yes, you are right. We always need a leader who knows how to go about a roadmap, and then you get the crowd to do the job. But crowd needs SOP, crowd needs micro leaders. Micro leaders can be drawn from the crowd, it not necessarily. And appointed leaders have always failed compared to micro leaders that develop within from the crowd. So you need a hierarchical structure. You need eventually a hierarchical structure, but the chief mentor, I call myself chief mentor, I don't call, I took that designation because I did not want to have any financial, because I was approving that time about $800 million of grant across the CSIR and the country. So it wouldn't be appropriate for me to operate financially. So I didn't want to be the chief PI, the word. I made it myself chief mentor. So I only give in principle approval and then the finance. So there was head, Dr. Bal Ganesh was brought from AstraZeneca after he was the director of the AstraZeneca Research Laboratory. In the beginning, he was a skeptic, then he converted and he came as a senior person to head the biological. IT part and the computational crowdsourcing part, I was still myself was following, because that didn't need money. And I didn't want to get into approving money where, because I am the final authority to approve all, so it doesn't look nice for me to do micro-funding approval. So therefore it needed, but if I had to do it today, I think it's all we need, a couple of people who are committed. I must tell you, I have learned one thing. The level of commitment is far more important than the level of intelligence. And level of loyalty, that believe in it, is far more important than how much brilliance you are. And I say to everybody, if you go to some of the YouTubes of mine, it will be sometime, during Christmas, I gave a talk to a Christian college saying that Jesus Christ had 12 disciples. He converted the world 25% people into Christianity. Whereas Buddha had only 2 disciples, but he didn't get them when he was alive. So nobody became Buddhist in India, although he was born in India. But some of these 2 disciples went to East and became. So you need 2 disciples. And I suggest that in this course, you can show a video, which is called A Dancing Guy on the Beach, a leadership example of 2 minutes. And you will see the leader has to vanish. Leader has to be invisible at the end, and you have to take followers who becomes leader. And then followers are followed. Leader is often crazy. Leader cannot be followed. A crazy leader cannot be followed. But the followers of the crazy leader can be followed, which is more human. And all you have to do, those 2 disciples should have been in sync with the crazy leader. So unless you got 2 disciples, don't start the project, who are ready to do what you believe in it. And then they can do anything, whether social transformation, public data generation, policy wiki, or making Las Vegas different. Everything is possible. But get the funding from lawyers, get lawyer friends to make sure that nobody can use your data and steal it. So I use Bartak Knoppers of Canada to write the comments. You have to sign and say that I will not take it away. I got a spicy IP group, Indians, some of the Basi, one of them, to help, and also some legal group from USA. And they actually helped us when other people trying to take away OSDD data and trying to use it for their private good. So therefore, I need lawyers, but only to protect open resource, because it is really an open asset created for public good, not private wealth. Because when people contribute, if any chance you make an economic benefit yourself, all your crowd will leave you. They don't trust you. So you have to make sure under no circumstances you don't make a personal economic benefit using a public crowdsource. Otherwise, you have to give them economic return for economic benefit. So therefore, I would say it's not easy. It's you have to have a very high ethical principles when you take public's wisdom to create public good, but you cannot use public's wisdom to create private good.
So I
That's
think
it.
we are, so Samir, there's one last question that's come in. I want to just test your patience and your time. We want to make sure to switch over to talking about projects in a minute, but I'm wondering if you want to take the last question that comes from James in the chat, or James, if you want to ask it.
Yeah, basically, I'm just wondering if it seems like most users are motivated by the sense of providing an addition to a public good. I'm wondering if there's also potentially the motivation of like, oh well, I have my own little space that I've also added that's personal to this, and I have sort of an identity within that, or like you spoke about how they're anonymous to each other.
Yeah,
Do they have any ways of sort of standing out as well?
Yeah, you have to understand these students are from remote India, where they haven't seen much facilities, and they are hungry. If they are not our IIT students or elite Indian Institute of Science students of elite institutions who knows the streets of New York and the building number of NIH, these are students who had no clue. For them to be a part of a national program itself is very exciting. Then the second point, as you said, I made sure that because I was accessible, that's why I said my position was advantageous. I made sure that Prime Minister in his Independence Day speech talks about OSDD, or ex-president makes a statement. When this happens, these children, it sees in the newspaper, something is said about OSDD, they run to their parents and show, you see, I'm contributing this OSDD. I'm a part of this OSDD. And this is a great, great motivation, great feeling for them that they are part of a larger story, and the story has a recognition nationally. So I think national recognition of OSDD was very important, especially in the political space, national space, scientific leadership space. In the beginning, it was all negative. Nobody believed in it. But slowly, as it started happening, people believed in it. And then the global people actually contributed to this. And several people wrote about it. And I'll be surprised that I don't have a Nature article myself written, but there are Nature write-ups. There are all other journal write-ups. Science has a write-up on me saying OSDD, but I have not written the Science article. Because we said our objective is not to write an article. I've written hundreds of articles. Our objective to build a model that will reduce the number of tuberculosis deaths. I noticed today 156 countries are meeting on the United Nations to decide 2030 targets. And I saw that 90% reduction of tuberculosis death was one of the proposed item of 19 items that has been shortlisted. So I believe it is a shame for humanity. It's a shame for all genomic scientists, molecular biologists across the world, that why should such an organism has evaded us, and why 1,000 people in India should die, why 4,000 people per day. So therefore, I think that was motivated young people to feel that young people are least interested in money. And especially in India, young people are most interested in doing something big and good. All the young people come to science to solve problems of humanity. And when they become professor, they realize my next grant, my next postdoc, my next award, next fellowship is more important and we forget the motivation with which you came when you were 22 years old, because you didn't know how difficult to solve the problems of the world. But that was the motivation that all of us had when we were very young. And we lose that as we grow older. And I hope that spirit, I'm sure many old people have this spirit, and I've seen them. I'm amazed by them. And so therefore, it should be possible that we can make a difference. And that's what I said, that it is very difficult for you in the United States, compare United States students, because my daughter is now at this moment a student in the United States doing PhD. I know how the students are. It's not going to be easy. But I can tell you, on a Sunday morning, Berkeley organized an OSDD talk by me. First time I used a chalkboard and talk. And they organized some cheap snacks, they could collect and coffee. They brought from home, and we all ate, and I talked. And then I was so emotionally got engaged, and I actually told them, I will take all of you for pizza. And we all, students were very happy to get a pizza. They were not interested in a nice French restaurant. They were just happy that they could get the talk, they would participate, and they eventually got a pizza from me. So I have seen, jokingly somebody tells me, Shamir buys me those, who are paid maybe $10,000 a day, lawyer and what do you call it, MBAs. They say Shamir buys me with a burger. And the joke, this is a joke that goes, I buy people with burger. I'm sure Beth will be bought and for OSDD as a champion.
One advantage to virtual teaching is that I don't have to buy any pizzas. We all bring our own coffee at 8 o'clock in the morning, at least on the East Coast, and whatever time zone people are in. And some of our participants, for them, it's 5 o'clock in the morning when we start.
Tell me how many students you expect, that this has also been heard, other than the people who are sitting here, who are giving their ideas.